Hello everybody, I'm Paul Beckwith, and in this video my main focus is going to be on this so-called bomb cyclone or sting jet that has been hitting Ireland and parts of Scotland and the UK. And because of the jet stream configuration, there's a huge dip in the jet stream over North America, which has resulted in snow in places like Florida and New Orleans, people ice skating on the streets. They've had, quite a bit of snow in some parts of Florida, like Pensacola and other places. And then the jet stream has this dip and then heads across the Atlantic and then swings up to Ireland. So it's all related. These are very, very fast jet streams. So I'll show you what's happening on Earth Null School and how the U.S. Snow in Florida is related to the massive storm hitting Ireland at the moment. Before I get into that, I picked up the latest version of the Atlantic February edition, and it's The Antisocial Century is an amazing article by Derek Thompson, explaining how our society has become much more antisocial because of people being confined in the pandemic, but then things continuing on since then. He has a lot of interesting examples. It talks a lot about social media, about smartphones, about our distractions in everyday life. There's also an article called Dispatches, the New Rasputins by Anne Applebaum, and it talks about how anti-science mysticism is enabling autocracy around the globe. People's belief in magic and mystery and, mysticism and things like that, and how what we're seeing today with some of these crazy beliefs of the far right especially, but also the very, very far left, is we've had all this before. They give the examples of just prior to the 1917 Russian Revolution, where society was starting to go bananas, basically, topsy-turvy, haywire. So this, if you want to understand what's happening in our society today, I would say have an open mind and read this. And this is the article by Derek Thompson, which is alluded to in the title, in the on the cover of the Atlantic, The Antisocial Century. Somebody eating alone in a restaurant, for example. That's way, way up just in the last couple of years. People going to a restaurant, eating alone. Back years ago, people, it was, people didn't do that, basically, because other people, they were concerned. Other people in the restaurant would think, hey, what a loser, eating alone. So it's a very detailed, long article, The Antisocial Century. Lots of good examples, lots of anecdotes, and I'm sure you can relate to it. Face-to-face socializing, how important it is and how we've been getting away from it. So highly recommend this edition of the Atlantic. Okay, so let's have a look at the Sting jet. Now, I mentioned this in my previous video, and I think I said this looks like a lobster claw to me. Well, I stand corrected. This is supposed to be the tail of a scorpion. Okay, the tail of a scorpion showing this Sting jet. So we'll get to that in a minute. Let's have a look first of all at what's happening with this storm. Okay, so, before I get there, this is the satellite image of the Thwaites Glacier. So this was the clear image from January 22nd. The day before, this was attached to the shore. So in one day, it swung out. And you could see a cloudy image on the 23rd. And on the 24th, nothing. Completely clouded out. So we'll have to wait to see, what developments there have been down there. Okay, so on X, Twitter, this is, where it's actually quite powerful, the app. I'm looking at Eowyn, the name of the storm. I'm sure I mispronounced that. Top stories. So basically, this is a storm that underwent explosive cyclogenesis, formed very, very quickly. The pressure in the center, in the low of the storm, dropped very, very fast, making it a bomb cyclone, but actually much, much faster than a bomb cyclone. I'll get into the details. I just want to show you some posts here, so you can see this thing coming towards and hitting Ireland and going through Scotland, etc. The team, here's weather and radar, UK, Ireland. The team recorded gusts of 190 kilometers an hour or 118 miles per hour. What does that mean? 190 kilometers an hour. You can look at the Atlantic hurricane scale, the Saffir-Simpson scale. 190 kilometer, that's equivalent to category 3 hurricane. Okay, just so you know, I mean, those winds are amazingly strong. So here's somebody walking against those winds, trying to measure things. Good job the wind is blowing this way. If it was blowing towards the cliff, I probably wouldn't be a good idea to do that. Okay, there's lots of, if you're wondering about why we're getting such insane record-breaking weather, like this storm, the LA wildfires, Valencia floods, this is a good place to start. Let's have a look at some other images. This is Galway. So storm surge, large storm surge in certain regions, the winds pushing the water up onto the shoreline, causing coastal flooding in Galway. Record-breaking wind gusts of 183 kilometers per hour. Okay, so this was last night, basically. Here is a van that's being impaled by a tree branch in Scotland. So this tree branch came down and basically impaled the roof of this van. You know, I guess it became airborne, came off the tree and became airborne and just pierced the truck. Here's some images of 8 a.m. this morning, local time, on a farm. Some of the mud and water and damages to different structures, etc. Some of the meteorology of this storm as it was coming across, dropping snow in parts of the US, very cold conditions, and then coming across and hitting Ireland and Scotland. Okay, this is a guy out West Belfast. He's out in his backyard, and a loose roof tile came down and just about hit him. Let's have a look. He's there, and look, you can see a roof tile flying off. Of course, there's a little kid's toy. You know, often when, people want to joke about these storms, they'll show an image of a little kid's toy that's on its side, or a lawn chair, plastic lawn chair, being knocked over or something, saying, yeah, look at the massive storm, right? And then you have the opposite where, yeah, I don't think this is true, silly cat in the wind. This is quite interesting. Some of it shows you some of the effects of the winds and the storm damage. Ireland and Scotland. Most trains halted. Millions of customers without power. Different structural damage and things, trees down. Right, from the high winds. Storm is expected to lift north, grazing Norway with snow. I mean, this is quite a video here. Lots of footage. Everybody's got smartphones. A lot of people have smartphones these days, and they'll film movies and post them. There's some house damage. I think a lot of the structures are built very well there. I mean, for Category 3 winds, I would expect to have seen more catastrophic damage. This is quite an amazing video. So this is a pilot landing a plane at Edinburgh Airport during the storm. And you have to be a really good pilot because it looks like there's strong crosswinds, and you know, with the wing motion like this, I mean, he nailed the landing. I guess the question is, why would you have a plane landing right during the storm? Lots of other stuff here. Here's a truck being blown over during the high winds coming off the road. I mean, there's all kinds of footage. 183 km/h winds. There's a trampoline on a train track. And huge winds, very, very large storm surge. And I'll show you how you can get all that information from Earth Null School. Okay, so you get the idea. Ireland's recorded its strongest ever wind gusts during this storm. Strongest wind gust to hit Ireland. Okay, so yeah, so basically, you know, this is where, you know, X/Twitter excels. You just put in the storm and you get all of this information at your fingertips. There's other apps that can do that. Okay, so this is Earth Null School. So just Google Earth Null School. You click on this image here, Earth, and we're looking at the winds at the surface, air winds at the surface, and you can see this is when the storm was approaching Ireland. We can go back a little bit. This is if we want to cycle forward with finer time scale. You can see the storm approaching Ireland and then going over, grazing the coast, and then heading up towards Scotland over time. Okay, so a massive storm. Let's go back a little bit. If you want to look at the ocean, waves, for example, this is you know, currents and waves, peak wave period, significant wave height. So then you would click on here, and it gives you the wave height. Okay, 40 odd feet off the coast. And if you just click on here, you can go to meters, change the units just by clicking on it. 12.5 meters of surf, plus the winds going this way, so big storm surge along the coast here and coastal damage. Now we can look at the look at the jet streams. So look at the winds at 250 millibar. So those are the winds at high altitudes aloft, and you can see the wind pattern here coming onto Ireland and Scotland and the UK here. And you can just click here and you can get the speed of the winds, kilometers an hour. Okay, so the strong, powerful jet stream crossed the Atlantic and brought the storm over Ireland. I expanded out here, and we've got here this is North America. So you can see the dip of the jet stream, and so the trough is going deep into the southern U.S., and that brought the very cold temperatures to all of these states in this region. It brought snow to Florida, brought very cold temperatures well below zero to New Orleans and a vast area. It brought in a lot of snowfall in this region, which is very unusual for it to be that deep south, but it's because of the jet stream slowing and becoming wavier. A big part of it is a very large temperature amplification in the polar region, specifically in the Arctic in this case. So the Arctic is warming at 4 times faster than the rest of the planet. So that lowers the temperature gradient or difference between the Arctic and lower latitudes. When that temperature gradient reduces, it slows the jet streams and they become wavier, more meridional, and stuck in place. That's why we've been having events that are days long of freezing temperatures in the US. Now, if you follow the pattern of the jet stream, lo and behold, it comes across the Atlantic over to Europe, where it brought this storm to Ireland and Scotland and other parts of the UK. So it's all connected. The climate system is all connected. And let's have a look at some of the news stories. So this is ABC News, different weather warnings that were there. So they said, you know, this storm was a danger to life. This is a video. You can watch it. I'll provide the link. I don't need to show it to you here. AccuWeather is talking about generational bomb cyclone Eowyn to slam Ireland, UK, parts of Europe. So that's happened, but basically this is called a bomb cyclone. And it's a bomb cyclone. A storm is considered a bomb cyclone when the barometric pressure, so the air pressure, falls at least 24 millibars in 24 hours. So a pressure drop in the center of the storm of a millibar per hour for 24 hours means that it's a bomb cyclone. This particular storm was actually at least double that rate of drop. So it was phenomenally quick drop of pressure, winds as high as 180 kilometers an hour, and they were actually clocked even higher. So it affected northwestern Spain, France, Denmark, southern Norway into Saturday after hitting Ireland and the UK. My friend Nick Breeze, who's a climate journalist, and he wrote the book Cop Out, doing an interview with him next week, maybe a couple with him. His plane was diverted in Spain to land somewhere other than it was supposed to be intended because of the high wind. So it's already affecting places, other widespread places. So this storm has been described as a generational storm, one of the strongest on record in Ireland, and it broke this wind record of 182 kilometers an hour that was set in 1945. I've never seen anything like it in my career, a BBC weather presenter said. The NOAA, National Oceanographic and Atmospheric Administration, they have these hurricane hunter airplanes that fly into storms to gather data. So they do this in hurricanes, tropical hurricanes, but it's also used to gather data on these types of storms. And so we need NOAA and we need these hurricane hunters to make decent forecasts. This NOAA, the National Oceanographic and Atmospheric Administration, is one of the government organizations that's been threatened with being chopped or eliminated completely by the new U.S. administration. Just wanted to point that out. Okay, so here's some images of the storm coming through. Okay, so there's lots of stuff on this. I showed you the Saffir-Simpson hurricane wind scale, and we've had winds gusts of up to 190 kilometers an hour, which puts it solidly into the Category 3 hurricane scale. Okay, that's the sort of thing so it's not a tropical storm. This scale is for the tropical storms, but we're seeing this extratropical storm go far north with Category 3 winds. So severe weather Europe is a good source of information. All these links, of course, will be in the description. But so let's see what they were saying. Ireland braces for Eowyn on Friday, the most powerful storm in decades, winds to be near 200 kilometers an hour. So it's one of the most violent Atlantic storms in decades. Destructive winds, significant waves, and extremely low surface pressure are forecast as a bomb cyclone grazes into Western Europe. Winds nearly 200 kilometers an hour to the west coast of Ireland. So it says, thanks to disruptions in the polar vortexes aloft, and I showed you the polar vortex is the high altitude winds, right? It circles the north, but the meanders in these waves in the meridional direction in the jet stream have become much larger, so we get these cold air spilling from the Arctic into the deep south, in this jet stream trough. Okay, so disruptions in the polar vortex aloft. Its deep southern lobe is emerging from Canada into the North Atlantic, allowing the explosive development of frontal waves, deep surface lows heading towards Western Europe. Okay, so they basically described it as a sting jet. Learn about the sting jet and why it brings such violent winds. So the sting jet basically brings the most powerful and destructive winds inside the mid-latitude Atlantic storms, with peak gusts of up to 200 kilometers an hour. So they show the stinger here of a scorpion with the claw, and basically these winds were called sting jets. So what are they? Well, you can see them on satellite here. So this is an image showing the storm as it's approaching. So this is from January 23rd, 2025 at 23:30 Zulu time. Showing the, black and white image, showing the motion. Of course, you have the low pressure in the center. Air coming in from all sides is higher pressure. It's deflected to the right in the northern hemisphere because of Coriolis force. So the winds are circling around this way. And you can see this fine structure here, which is known as a sting jet, and that's where the highest winds are. So here's another image. Here's another image with false color, and you can see the sting jet here. We had extreme pressure drops observed off the coast of Ireland in the ocean buoys. Okay, so there was an oceanic buoy, or buoy, M6, showed that the pressure near the core of Eowyn is very impressive. So the pressure drop at the buoy, within the last 10 hours was 49 millibar pressure drop in 10 hours. That's like about almost 5 millibar per hour. That's like unheard of, right? The criteria for a bomb cyclone is a 24 millibar pressure drop in 24 hours or 1 millibar per hour. This is like 5 millibars per hour over 10 hours. And the last 6 hours showed that the pressure drop was 38 millibars. So that's over 6 millibar per hour drop. 6.3 in fact, which was very, very high for so long, over many hours. So this is the ocean buoy. This is the pressure, 992 millibar, right? Normally atmospheric pressure is 1017 millibar on average. So we've got a storm coming, pressure's low, and then look, it just dropped off a cliff. So the blue transition is 49 millibars in 10 hours, of which 38 was in the last 6 hours, okay, from here to here. So just a phenomenal, and down to 947 millibar minimum pressure. They talk about extrapolating. If that was maintained for 24 hours, that would be 152 millibar drop. That's physically impossible, since the deepest part of the storm usually lasts up to about 12 hours. But it just shows you how extreme this storm is. So the bomb cyclone criteria is 24 millibar drop in 24 hours. This storm had 6 times faster over shorter periods of time. And the wind gusts exceeding 180 kilometers an hour, reached 200 kilometers locally, was what they were forecasting. So their forecasting was pretty good. They were showing 216 kilometers an hour in the model here. Let's go back to the Saffir-Simpson. 216 kilometers, that's hitting category 4 hurricane, right? It's just mind-boggling how powerful this storm was. So, another term used is bombogenesis, the genesis of a bomb cyclone. Very impressive data from the satellite data, some weather charts showing all the different cold fronts advancing, warm fronts, how they meet, where the central pressure was when it was still out in the Atlantic. So the forecasts, I'd say, were pretty good. They were saying that it would make landfall at about 935 millibar, and it was very fast moving, and wave heights were huge. This is a zone where they expected the highest winds just before hitting Ireland. Okay, so there's lots of updates here. Okay, and then I just wanted to show you, this is an article from October of last year on severe weather Europe. What is a sting jet? Okay, so that's what we have in this case. So a sting jet is a narrow core of violent winds. It sometimes forms within the rapidly intensifying North Atlantic and North Pacific extratropical cyclones. So when we talk about tropical cyclones, right, they can lead to the tropical storms, which can then become hurricanes all the way up to category 5. But this is a different beast. This is extratropical. It's not in the tropics. We get powerful windstorms developing high aloft, and then the windstorms go down towards the ground, and we get very high surface temperatures at the ground. And these sting jets are associated with the strongest and most damaging windstorms, resulting in violent hurricane force winds. How do they form? Okay, so the most damaging type of these extratropical cyclones, you get the formation of a bent back front and a cloud head that's separated from the main polar front cloud band by a dry slot. When the cyclone bottoms out at its minimum central pressure, the trailing tip of the cloud head bounding the bent back front forms a hook that goes on to encircle the seclusion or inclusion of warm air. So the highest winds occur near the tip or the nose of the hook, the sting at the end of the tail. So this was where this comes. You've got the scorpion tail, you've got the sting here. That gives it the name sting jet. Okay, so it's, is it a bit too scientific? Well, it's not complicated. So the sting jet definition. Okay, so deep North Atlantic cyclones, they often graze into Western Europe with damaging wind and waves. I should point out that James Hansen, remember the book he wrote, Storms of My Grandchildren? He wrote it like over a decade ago. Well, these sort of things are happening now. These are storms of his grandchildren. And hopefully his new book, Sophie's Planet, comes out soon. He's, if you don't follow his work, I think you probably should. I mean, in my mind, he understands the climate system more than just about anybody else. We were fortunate to interview him on Climate Emergency Forum, and we'll have to do that again very soon, I think. So storms Eunice, Leslie, George, and Ophelia in recent years have been this sort of phenomena. Sting jet is a meteorological phenomena blamed for producing violent hurricane force winds, with the most notable event. So you get peak wind gusts well above 150 kilometers an hour, some even surpassing 200 kilometers an hour. So this is showing the storm here when it was still out in the Atlantic off the coast. This is water vapor. This is an image of water vapor. So sting jet is a relatively narrow zone of the very powerful wind maximum originating from inside the mid-tropospheric cloud head within the explosive cyclogenesis or bomb cyclone. That's a handful of words. Basically, there's two frontal zones. There's a warm front and a cold front. A strong flow of cold air develops into the cyclone ahead of the warm front. That's known as the cold conveyor belt. And then you can get a dry intrusion of relatively drier air that goes into the center of the deepening low. And so you get this sort of formation. This is what it looks like, and the sting jet comes off from the end here. This is a textbook example of a sting jet, basically like a stinger here. I think they're referring to the whole thing in this case. So they show here you've got a warm front here, you've got a cold front advancing. You get this sort of rotation because of the Coriolis force. right? Winds coming in, deflect to the right, so you get this counterclockwise rotation. You get dry intrusion of air coming in here, and this is how the sting jet forms in this region where you get the highest winds. And they show here, this is actually really clear here. The strongest wind is occurring in the channels. So you've got these banded cloud formations, these like spikes here, and the strongest winds are in the channels of clearing, indicative of stronger descending branches of air. So you've got very fast winds in the high jet stream, and then the winds descend to the surface and cause tremendous hurricane force damage. And this is another image of the scorpion's tail, basically. A sting jet usually affects only a small region of about 100 to 200 kilometers or 100 to 125 miles across. It's compared to the size of the parent large bomb cyclone. It's pretty narrow. It usually only lasts for several hours, but destructive winds will occur, and they show here some wind analysis of the cyclone and the cloud band and how these things are forecast. You know, look at this chart here. I mean, look at these striations here. You know, that's really, really pronounced. Okay, so then they talk about some previous events and so on. You know, Scotland, January 3rd, 2012, textbook appearance of a sting jet, 172 kilometer winds in the Netherlands. The Isle of Wight had 196 kilometer-hour gusts, or 122 miles per hour, during windstorm Eunice on February 18, 2022. Well, let's go back to our Saffir-Simpson scale. 196 kilometers an hour. Yeah, it's just crazy. Just crazy, you know, strong category 3 winds. Leslie, October 14th, 2018, wind gusts up to 176.4 kilometers an hour in Portugal, extensive damage. This is showing this particular storm with the sting jet down here. Okay, and they give examples of other storms. Hurricane Milton, sort of sting jet here. Okay, so these sting jets are happening. You know, there's another meteorological term for you, which we didn't have just a short number of years ago. Anyway, thank you for listening. This is sort of the meteorology and some of the climate behind, you know, why we're getting these master storms. And I really think that James Hansen nailed it in his book a decade ago, Storms of My Grandchildren. And like I said, I'm really looking forward to his book coming out soon. It's been coming out, it's supposed to be soon, you know, for a year and a half, I think. So I kind of forgot about his book, but was reminded of it earlier today. Anyway, thank you for listening. Please consider going to my website, paulbeckwith.net, and donating at PayPal to support my research and these videos. Thanks again, and bye for now.